Hi, in this video we're going to learn how to calculate the pH. So our formula over here is H3O plus. Concentration of H3O plus, remember bracket means concentration, makes converting to pH, which will be converting to POH, which can be converted into OH minus. This looks really similar to what we learned in Unit 2, right? Grams turning to molecules, grams turning to moles, to molecules, to atoms, etc. Yeah, so this is the same concept, except this time we're dealing with different stuff. Now, first thing, H3O plus is basically OH. H3O plus and H plus can be used interchangeably as of now. And this is a concentration of our H plus or H3O plus. Now next, pH. To go from the concentration of our hydrogen to the pH, we're going to use the formula pH is equal to negative log of the concentration of H3O plus. And the other way around, the concentration of H3O plus is equal to 10 to the negative pH power. Let me give myself a little bit more room here. Next, I have POH. Now, POH is just like pH, except it's a measurement of the number of hydroxide ions. Because if you remember, pH is the concentration of hydrogen ions. So, POH, from pH to POH, you're going to use this formula. pH plus POH is equal to 14. And it's vice versa as well. POH plus pH should be equal to 14. And finally, from POH, you can get the concentration of base. OH minus is the concentration of the base. And you're going to use the formula POH is equal to negative log of the concentration of OH minus. And the other way around, you're going to use the concentration of OH minus, the concentration of the base, is equal to 10 to the negative POH power. Now, if you take a look at this if you want to guess from the concentration of our hydrogen cations if you want to guess from the concentration of our acid to the concentration of our base, it's going to take a lot of work. So there is a shortcut, and it goes straight from H3O plus to OH minus. And the formula here is concentration of H3O plus times the concentration of OH minus is equal to 1.0 times 10 to the negative 14th power. And this is also equal to Kw. Kw is the equilibrium for water that we're going to use later. So right now you don't really need this, but it's good to know. And this is how you get, if you're given either one of these, you can find the other, because we know what it should be equal to. Now let's do an example. First, let's start off with an easy one. We have a POH of 6. What is the OH concentration? What is the pH? And what is the H plus concentration? Again, H plus and H3O plus can be used interchangeably. So right now we know the POH is 6. Let's do the easy step. 6 plus something has to equal to 14. That means the pH has to be equal to 8. Now, from POH to pH, POH is equal to the negative, OH is equal to 10 to the negative POH power. So OH minus is equal to 10 to the negative 6th power, which we can use as 1.0 times 10 to the negative 6th power. And H plus is the same thing. Let's see, H plus is equal to 10 to the negative pH power. The negative pH power, which is 10 to the negative 8th power, which we can also rewrite as 1.0 times 10 to the negative 8th power. Now, if we're asked, is this solution acidic or basic? When we're determining if something is acidic or basic, we're only going to look at the pH, not the POH. Alright, the pH is 8, so that means this is a basic solution. And here's something else I should know when rounding with pHs. So when you're using pH, you would round to 3 decimal places. Okay, you're always going to include 3 decimal places, and that is how you write the correct number of significant figures for pHs. Now let's go on the harder example. So our question here states potassium hydroxide has a concentration of 4.65 times 10 to the negative 7th molar. And remember, molar is concentration. Find the concentration of hydromium in hydroxide ions. Potassium hydroxide is KOH. Now, we can use our formula. It said this has a concentration of this. Find the concentration of hydromium in hydroxide ions. Okay, so we have our concentration of H3O plus times our concentration of OH minus, resulting in 1.0 times 10 to the negative 14th from here. So we're given that KOH has a concentration of this. So this will be here, 4.65 times 10 to the negative 7th power. And now all we have to do to get this is divide this number by this number, right? So 1.0 times 10 to the negative 14th divided by 4.65 times 10 to the negative 7th. And that should give us an answer of 2.15 times 10 to the negative 8th. So now that we know the concentration of our acid over here is 2.15 times 10 to the negative 8th power, and our concentration of potassium hydroxide is 4.65 times 10 to the negative 7th formula, times 10 to the negative 7th, using our formula that we have up here.